What if I told you that on December 22nd, 2025, the universe slipped for just a moment, and in that slip, we may have found proof that we are not alone? At exactly 2 UTC, a forensic analysis of the interstellar object known as 3I Atlas revealed something that should not exist in a chaotic cosmos. It wasn't a strange color or an unusual orbit. It was something far more unsettling. A rotational signature so precise, so mathematically exact, that its probability of forming through blind natural processes was effectively zero. In a universe governed by entropy and disorder, this object was keeping perfect time. Imagine a rock traveling billions of kilometers through total darkness, shaped by violent collisions, flung from one star system into another. No atmosphere, no guiding hand, no stabilizing force. And yet, 3I Atlas was spinning with the steady rhythm of a Swiss watch. Even more disturbing, its axis was pointed almost directly at our sun. The telemetry no longer described a drifting comet. It suggested intent. It suggested control. In verified rotational mechanics, natural interstellar bodies are expected to tumble. They spin chaotically in what scientists call non-principal axis rotation. These objects are born in catastrophic impacts, and once cast into deep space, nothing exists to calm that chaos. No air to create friction, no gravitational anchor to lock their orientation. They wobble endlessly. That is the rule. But ground-based simulations from observatories in Calabria, Italy, showed that 3I Atlas completes one rotation every 7.136 hours, with a precision of 0.01 hours. That is not tumbling, that is cadence. As the object approached the sun, massive outgassing jets erupted from its surface. In any natural comet, these jets act like random thrusters, altering spin rates dramatically in a process known as non-gravitational acceleration. Water production increased 20-fold near perihelion. That alone should have caused a measurable spin shift. Yet observations from the Hubble Space Telescope confirmed that 3I Atlas did not drift by even 3 minutes from its 7-hour rhythm. Something was canceling the torque. Theoretical modeling revealed a striking possibility. 3 jets, spaced exactly 120 degrees apart, firing in symmetrical coordination. In vector physics, equal forces positioned at perfect thirds around a central axis cancel out net torque. The result is balance, perfect balance. Nature produces fractures and irregular vents. It does not build equilateral manifolds with millisecond synchronization. This looks engineered. Then there is the alignment problem. The spin axis of 3I Atlas is locked toward the sun within 20 degrees. In celestial probability terms, that alignment has less than a 3% chance of occurring randomly. It is as if the object knows exactly where the sun is and has positioned itself accordingly. That orientation would maximize solar energy collection or maintain a stable line of sight for a high-gain transmission system. In orbital thermophysics, such alignment also ensures uniform heating, preventing structural cracking. This object is not merely surviving the sun, it is using it at its equator. 3I Atlas moves at 320 meters per second. That speed approaches the structural failure limit for a loose aggregation of ice and dust. A natural dirty snowball would have disintegrated months ago under centrifugal stress. Yet it remains intact. This suggests tensile strength comparable to advanced carbon composites or metallic alloys. 33 billion tons of mass, held together by something stronger than gravity alone. Beneath its rugged exterior may lie an internal skeletal framework designed to endure enormous rotational forces. And this is where the story becomes impossible to ignore, because that 7-hour spin is not just a physical property, It is a chronometric signature. In a universe filled with random frequencies, 3I Atlas performs like a metronome. Researchers studying the slight 20-degree wobble in its jets identified phase-locked behavior. That wobble is not instability, it resembles a scanning pattern. Every 7 hours, the object completes a full 360-degree sweep of its surroundings. It is not drifting blindly through our solar system, it is observing it. And as it continues its silent rotation, we are forced to confront a possibility that challenges everything we thought we knew about the quiet sky above us. Because if that 7-hour rotation is not an accident, then what we are witnessing is not a comet, it is a system. And to understand why this has unsettled astrophysicists across the globe, we have to look at one of the most fundamental laws of physics, the second law of thermodynamics. Entropy rules our universe. Left alone, every system moves from order toward disorder. Interstellar debris fragments, spin states degrade. Motion becomes chaotic. A comet traveling through shifting gravitational tides should wobble with overlapping frequencies, a behavior known as non-principal axis rotation. That is the expected outcome. But 3I Atlas is doing the opposite. It is maintaining what can only be described as zero entropy spin. Even as it passed perihelion, enduring violent solar heating and asymmetric outgassing, its rotational period did not change by more than 0.01 hours. In classical rotational dynamics, that level of stability under such uneven torque is physically implausible for a natural object. One explanation rises above the rest: active stabilization. Theoretical models suggest that 3I Atlas may be shifting its internal center of mass in real time. To maintain a constant 7-1-hour rhythm, while ejecting tons of surface material every second, internal mass redistribution would be required. That is advanced angular momentum control. On Earth, we use reaction wheels to stabilize spacecraft like the Hubble Space Telescope. Scale that concept up to a 3 billion-ton body, and you begin to see the implications. High-resolution imaging in early 2026 strengthened this argument. The 3 jets were not just present, they were geometrically perfect, exactly 120 degrees apart. In vector physics, 3 equal forces separated by equal angles produce zero net torque. This is deliberate symmetry. By spacing its exhaust vents in this precise triangular formation, the object can approach the sun, release material, and still preserve its rotational tempo. Geological randomness does not produce equilateral engineering. The axis alignment deepens the mystery. Statistical mechanics tells us the probability of such precise orientation relative to the sun is below 3%. Yet 3I Atlas remains locked within a narrow margin. That positioning creates an optimal configuration for solar energy extraction. By spinning with its equatorial belt exposed to consistent sunlight, it ensures uniform thermal input. It is not simply passing through our star's domain. It appears to be refueling. The equatorial velocity of 320 meters per second pushes the structural limits of any loosely bonded icy body. Natural comets are held together by weak intermolecular forces. At this speed, centrifugal stress should exceed yield strength, causing fragmentation. Laser altimetry data shows no bulging, no flattening, no structural compromise. The nucleus remains rigid. This points to a high-tensile internal lattice, perhaps a carbon nanotube framework or metallic composite acting as a reinforcement cage. There is another possibility. By spinning at the threshold of structural tolerance, the object may be generating artificial gravity for internal systems, overclocking its rotation to produce measurable centrifugal acceleration would allow internal mechanisms to operate in a stable environment. That is not survival behavior. That is functional design. When viewed through the theoretical scale of advanced civilizations, a society capable of controlling angular momentum at this magnitude would classify as Type 2, able to harness energy at the scale of an entire star system. If that is true, then the 7-hour spin is not random motion, it is the heartbeat of a sentinel. As 3I Atlas continues its sweep through the inner solar system, its scanning pattern grows more pronounced. The slight rhythmic wobble in its jets resembles phase-locked calibration. It feels less like instability and more like measurement. And if this is measurement, then the question shifts from what it is to why it is here. Because the silence of space no longer feels empty, it feels timed. And that clock is still ticking. And if that clock is ticking, then the next question becomes unavoidable. What exactly is it measuring? At 19 UTC, a coordinated cross-correlation study between the Hubble Space Telescope, NASA's Deep Space Network, and the Very Large Array delivered a conclusion that changed the tone of the investigation entirely. The 7-1-hour rotation of 3I Atlas is not a passive mechanical state. It behaves like an active, multispectral scanning protocol. Researchers focused on the subtle 2-0-degree rhythmic wobble within the exhaust plumes. At first glance, it appeared to be minor instability, but deeper analysis revealed something else. The pattern matches the operating principles of synthetic aperture radar, or SAR. In signal processing, SAR systems use motion over time to construct images with far higher resolution than stationary radar beams. Movement becomes the tool for precision mapping, and 3I Atlas is moving with absolute mathematical consistency. Every 7 hours, as it completes a flawless rotation, its 3 symmetrical jets act as phase-locked reference points. Instead of merely stabilizing the spin, they create fixed calibration anchors. The object effectively sweeps a rotating multi-point emitter across the solar system at constant angular velocity. That is not drifting, that is surveying. If this interpretation is correct, then 3I Atlas has been constructing a 3-dimensional map of our Sun, planetary orbits, asteroid belts, and possibly even our artificial satellites. With sub-millimeter resolution, the idea sounds extreme, but the mechanics are sound. A stable rotational cadence combined with known electromagnetic interactions allows for detailed environmental sampling. Through resonance theory, compatible vibrational frequencies can exchange information with minimal loss. The 7-1-hour cycle may not be arbitrary. It may be tuned. Data simulations suggest that at an equatorial velocity of 320 meters per second, the object generates a localized magnetohydrodynamic field as it interacts with the Sun's magnetic lines. As it spins, it cuts through those invisible structures, producing Lorentz forces that can be modulated. In simple terms, it may be turning its entire 3 billion ton mass into a planetary scale antenna, a tuning fork resonating with the magnetic heartbeat of the solar system. That includes us. Our radio emissions, satellite telemetry, radar pulses, and magnetic fluctuations radiate outward constantly. For decades, we assumed the cosmos was silent, but if 3I Atlas is equipped to detect and analyze electromagnetic leakage, then it is sampling the signature of human civilization in real time. This aligns with the theoretical model of a Bracewell probe, an autonomous interstellar sentinel, designed to observe developing societies until they reach a specific technological threshold. Photometric logs add another layer to the case. A natural comet's brightness fluctuates unpredictably as fragments break off and jets vary in strength. its light curve resembles a flickering candle. But the amplitude modulation of 3I Atlas remains stable to within 0.01% even during peak solar heating. In control theory, such consistency implies a closed-loop feedback system. Something is adjusting output in real time to maintain signal clarity. If this is true, then the 7-hour rhythm is more than spin. It is synchronization, a steady carrier wave ensuring data integrity. And if data is being gathered with this level of precision, then one final question demands attention. Where is that data going? Because information, according to special relativity, cannot travel faster than light. That limitation shapes every communication system we have ever built. Yet during multiple 7-hour cycles, the Deep Space Network detected faint, phase-shifted pulses that were not directed toward Earth. They were aimed at the Sun-Earth L1 Lagrange point, a gravitationally stable location roughly 1.5 million kilometers from our planet. L1 is often used as a parking spot for solar observation satellites. It provides uninterrupted views of the Sun while maintaining gravitational balance. Theoretical analysis now suggests that 3I Atlas may not be operating alone. It could be part of a distributed sensor network. The rotating body we observe may be the mobile unit conducting high-resolution scans, while a stationary relay platform positioned near L1 handles long-distance transmission. In that scenario, the data collected during each 7-1-hour sweep would be transmitted locally to a hidden node, then forwarded outward toward its origin. The phase shifts detected in the signal align with directional targeting toward that gravitational waypoint. If accurate, this implies coordinated architecture, not random bursts, not noise. Meanwhile, structural measurements continue to challenge natural explanations. At its current spin rate, centrifugal forces at the equator approach material yield thresholds. A loosely bound comet would bulge outward, flatten, and eventually fragment. Laser altimetry shows none of this. The nucleus remains rigid, maintaining geometric integrity under stress. That suggests an internal skeletal lattice capable of resisting extreme tension, perhaps metallic hydrogen reinforcement or a carbon nanotube weave. 33 billion tons of mass, rotating at the edge of structural failure, yet showing no sign of degradation. This is not passive endurance, it is controlled performance. As 3I Atlas begins its gradual journey back toward the outer solar system, one conclusion becomes difficult to avoid. The 7-1-hour period was not just a number discovered in a dataset. It functioned as a timer, a countdown, a diagnostic cycle. If the scanning interpretation is correct, then during its passage through the inner solar system, the object completed multiple full surveys of our technological footprint. We have been measured, our electromagnetic emissions cataloged, our orbital infrastructure mapped, our energy output quantified. For decades, humanity has searched the sky for signals. We listened for structured transmissions, for deliberate messages embedded in cosmic noise. What if we misunderstood the process entirely? What if advanced civilizations do not announce themselves with greetings, but instead deploy silent observers machines that watch, evaluate, and move on? Through the lens of advanced civilization theory, a Type 1 society controls planetary energy. A Type 2 civilization commands the power of its star, an entity capable of engineering a 3 billion-ton probe with active angular momentum control, phase lock scanning, and solar refueling would exist far beyond our current capabilities. To such intelligence, our physics would not be limitations but tools. The rotation remains steady, the axis stays locked, the cadence does not falter, and as 3i Atlas retreats into deeper darkness, it leaves behind a realization that is both humbling and unsettling. The silence of the universe may never have been emptiness, it may have been observation, and somewhere, beyond our sight, something now holds a complete blueprint of who we are.